This is the Three Gorges Dam in China. The largest hydroelectric dam ever built, big enough to contain most major cities in the world, like New York, Paris, and London. It generates over 95 terawatt-hours of electricity per year, about 1/3 of the UK's total annual electricity demand. Now, China is planning something bigger, much bigger. A dam that could generate over 300 terawatt-hours of electricity, nearly 3 times that of the Three Gorges itself. But the real story isn't how big this dam is, it's where it's being built. From this plateau flow rivers that support nearly 2 billion people. The Yangtze, the Mekong, the Yellow River, and the river at the center of this project, the Yarlung Tsangpo, which becomes the Brahmaputra River in India, and then Jamuna River in Bangladesh, and eventually flows to the Bay of Bengal. This river alone supports over 100 million people across China, India, and Bangladesh. It irrigates farmland, supports fisheries, provides drinking water, and China controls its source. The proposed dam would sit in a deep Himalayan canyon, one of the steepest river drops on Earth. Experts say the hydropower system will be a feat of engineering unlike any ever undertaken. The system is expected to consist of an upstream storage dam that creates a reservoir that would provide steady water flow downstream. This would be followed by a diversion dam intended to divert water through the mountains into a tunnel system containing 3 underground hydro stations, and eventually ending in a downstream re-regulation dam. The final dam could regulate water when it flows through the tunnels and back into the main river. Engineers estimate it could generate over 300 terawatt-hours of electricity every year, enough to power tens of millions of homes. Supporters say this is about reducing coal use, meeting climate goals, powering China's economy as growth of AI and data centers will require huge amounts of energy, and all of that is true. But dams don't just generate electricity. They control timing, volume, and flow of water. When a dam sits upstream, it gives its owner the ability to decide when water flows, how much flows, and who feels the effects downstream. This isn't hypothetical. Studies show that even small upstream flow changes can disrupt agriculture hundreds of kilometers away. Now imagine a dam of this size. Downstream countries, especially India, have raised concerns for years, not because they oppose hydropower, but because water security is national security, and once a dam is built, there is no undo button. There's another problem. This region sits near active seismic fault zones. The Himalayas exist because tectonic plates are still colliding here, right now. Large reservoirs add massive weight to the Earth's crust. In some cases, dams have been linked to reservoir-induced earthquakes. A failure here wouldn't just be local. A sudden release of water could devastate entire river systems downstream. The higher the dam, the higher the stakes. Megadams don't just reshape rivers, they reshape lives. Tens of thousands of people live in the counties where the projects will be built. Among them, indigenous groups, including the Monpa and Loba people, 2 of the country's smallest officially recognized ethnic minorities. Ecosystems downstream lose natural sediments, fish populations decline. The Brahmaputra carries one of the highest sediment loads of any river on Earth, sediment that replenishes farmland in Bangladesh. Trap that sediment behind a dam, and fertile land slowly disappears. These effects don't show up overnight. They appear years later when the concrete is already permanent. China's next megadam might power cities, cut emissions, and redefine engineering limits. But it also raises a harder question. What happens when the source of life for millions sits behind a wall controlled by someone else? Because in the 21st century, the most powerful resource may not be oil or data, but the rivers that keep everything alive.